Okay, hello, welcome to another case solved. Today I'm doing the Around the World in 80 Days. This was the community case for this week. Usual caveats. I've obviously looked through the case a number of times, worked out how to do it, what approach takes is best. I've done some of this prep work so that this walkthrough is as efficient as possible, so not wasting anyone's time. And I will say a little bit about my own performance, which was very, very less than stellar as we go along, if I can remember to do so. But yeah, I think that's enough to say to introduce. Let's get going. So in terms of data, we've got most of the data is in kind of the main page, but we've got a couple of extra tabs, some weather conditions, a map to do with elephant movements through the mountains, and a ferry timetable. But yeah, let's get straight into it. So level one. Fortunately, the way the data is here, we can actually just do this as a kind of single XLOOKUP, because also the categories for the train and the ferry and the weather were all unique. There was no replication, so none of the categories, appear the same in each one. So if we do a single XLOOKUP, we get all of the answers. So we can then just sum that and multiply it by 60, and we get our answer. And if we fill that down, we won't get anything correct because we didn't lock the references. Unfortunately, we would know that straight away. So that's one of those errors that you tend to, if you make it, you still correct it generally, but not always the case. Okay, level two, we're going to go to a data table. It already, in each of these 2, 3, 4, and 5, you have to grab the answer from the previous level. So I've just done that before. So that's just a simple XLOOKUP into my answers. So we need to work out where this person is traveling. So their starting points before their journeys are these first 5 columns. And I'm going to wrap that in a 2 col. And then their ending points is the same, but it's the last 6 or last 5 even. So the travel time, we're going to XLOOKUP the start times and the end times in our from and to, and then return the 2 times. And we're going to put in, actually I'll show you how there's an error that we'll see, and it is one of those we will spot. What we want to know is the wait time is basically if there is somewhere to go. So if this stop doesn't equal X, which is what they use to say there's no further stops, then we have a wait time of 12. Otherwise, we don't have a wait time at all. And then we sum these 2 together. And then the final times, that's in hours. So we need to say that times 60 plus the original start time. And we get 6900, and we're going to have some errors, which will then correct, because if we go to example 22, we see that this error here is causing us an issue. So if we simply just say, if we don't have anywhere, then give us 0 travel time. And if we go back to level 2, we've got ticks all the way down. Right, level 3, again, just taking the previous answer. So we need to know how many minutes this is in terms of days. So we'll just take that and divide by 1440. And then we need to know what the next day is. So we're in the 4.7 days, which is the kind of 5th whole day, but actually the sequence, the next day is actually kind of that plus 1. So what I'm going to do is round up that by 0 and then add 1, because what we call day 0 they call day 1 is what's going on there. So I'm then going to create a sequence up to 80, because we know there's 80 days in the weather chart, starting at day 6. So those are the days we're going to travel. Now we need to look at our weather and work out the ship speed based on the day number. So we're going to XLOOKUP the weather type over here and return the weather speed. And then I'm going to grab all of these and name them based on the selection. So now we can say XLOOKUP this in our day num column and return the ship speed. And we've got our speed each day. We need to know the base speed. So we're going to XLOOKUP what's up there in C1 in the ship type and return the ship speed. And so our actual speed will be the base speed times the weather speed. Our daily distance is going to be however minutes we can go in an hour times 24 hours. And then our running total, or distance still to go, is going to be a scan where we start at 6,200. That's the only distance we're given. We're going to go over this array and we'll do a lambda where we take our accumulator and our value and we minus the value away from the accumulator. So that just keeps going down until we hit 0. And then from the example, we know that we hit 0 on the 23rd day, or so what we want to do is we want to XLOOKUP 0 in this range, find what day it is on, but we need to look for exact match or the next smaller item, because we're actually going into negative. So that happens on day 3. So then we need to know how much do we have left to do on that. So if we look up the day in the sequence and return the distance, we actually want the day -1 because we want to know how much there is the day before. So it's actually n4 -1. So on the day before we had 248 still to go. So our final speed is we're going to, on that final day, we're going to look up 23 in the sequence and return the actual speed, which is 20, and then we want to say how many hours did we have on that final day. So speed equals distance over time. So time is distance over speed, so it's distance divided by that. So there's 12.4 hours on that last day. So then our final time is going to be, I have to get this right, so we want to take the number of days, although we want to -1 because of that weird thing where day 0 is not the same as day 1, and so that's the number of days for the whole minute. And then we're going to add the number of hours times 60 minutes per hour. We get 32424. And I'm just going to double check my working here because I've got a feeling there might be a couple of errors if I've repeated a mistake from somewhere else. No, I haven't. Okay, that's good. Right, let's go on to level 4. So level 4, we're going to go to the elephant. What we're going to do is we're going to copy the colored bit of the map. We don't need that shaded bit at the end. I'm then going to use my fill with kind of cell color or cell color lambda, do the same thing over here, because now what I can do is I can look up this range here, which I know it looks like errors, but trust me, there are numbers in there on this range, and return this range, and we get a bunch of numbers. And I'm just going to copy and paste those as values only, so we're not using up computational power, and I'm going to name that MP for map. And so now if I go to the case, I can say, right, we need to find out the column number, so I'm going to take this and combine it with 1 to make a cell reference. I'm then going to wrap that inside a colnum lambda. We get 27, and I'm going to, but because we missed out the first column, we're going to -1 from that, and then I'm going to index into the map. We need the whole of the column, so we don't need a row number, and then we'll just point to that, and then we're going to wrap that inside a sum, and we get 4010 or 4110, which is what we'd expect. And these are pointing to the wrong cells. They should be pointing to that, because I did an extra helper cell on this example. Okay, now we go to level 5, and so in the real case I got to level 5 and I had felt like a decent amount of time, and I thought, oh yeah, let's see if I can get level 5, ignoring the fact that we were told that level 6 and 7 were easier. And I think I've learned from this is I always need to do the easy in order, rather than, because I basically thought I had level 5, entered my answers, they were all wrong. 1 minute later, after the case ended, I realised there was a silly mistake I'd make and would have got them all right. But there you go. And I hadn't done level 4, 6 or 7. So there you go. Right, so we need to work out the total minutes. This is starting from level 3 and level 4. But we also need to add these 5 days. So we're going to add in 5 times 24 times 60. So our starting point is 43,000 minutes. We're going to work that out as days, and now I'm going to do some work in the ferry timetable. So firstly, I want to work out the routes. I'm just going to do unique of the from and to routes, and we realize there are actually only 3 routes: Calcutta to Hong Kong, Hong Kong to Yokohama, Yokohama to San Francisco. So let's just copy that over here, and then let's do a little bit more work. So we basically want to find a way to combine this into a single date and time. So what I'm going to do is I'm going to take a sequence I'm going to start on, I'm going to do a sequence here of 100, starting at 0. I'm then going to just write the 1st of January up here, and I'm going to say, right, give me another sequence of 100, but starting on the 1st of January, even though that's 1st of January 2026, doesn't matter, because what we can then do is say text of this hour dash minute, not that, day, month. Okay, and now we've got dates and years. So what we can say is we want to say the departure time. So let's look up the date in this range over here and return this number. So again, something's gone wrong with my XLOOKUP. Oh no, it's fine. So what is day 1 in the kind of program is actually day 0 for us, because 0 days have a lot completed at that time. We then want to add to this the time, and that gives us all of the departures in kind of decimal times. Our arrival is simply going to be our departure time plus the travel time, but our travel time is in hours, so we want to times that by, and again it's not selecting it as it's not a built array, so let's just do that. And this is the bit I'm going to always get wrong, so it's hours, so we want to divide, not divide, yeah, we want to divide by 24, and that looks good, so we arrive at an exact time. So these are our departure and arrival times. Now let's select all of that, convert it to names from selection, go back to level 5. So now what we want to do is we want to XLOOKUP the from time and the to time, or the to location and the time, and we want to look that up in the ranges from and to and departs, and we want to return the arrives time, but we want the exact match or next larger item, because we can't depart until after we've left. So then that becomes our start time for the next one. That's the earliest we can leave, is that arrival time. So I'll fill that down and do the same over here, and we get all of our times, and then we're just going to take that and multiply it by 1440 to give us the minutes, which works to the example. And the reason I was wrong on my original work is I'd forgotten that thing about the 0 day, so I was counting, I basically had an extra day in all of these, and so that's why my calculation, and it wasn't even matching up for the example, so that's why I knew we couldn't go. Just to do a bit of illustration, what we could say is if we take the integer value of these, we see that's the kind of day we're on, and if we XLOOKUP those, and if I just refer to my fairy timetable on the 0 kind of sequence, we get the actual dates, and if we take the modular value of these to 1, we get the actual times, and that matches with, you know, Feb 7, 9 p.m. and so on. Okay, let's move on to level 6. I'll just check level 5 actually is correct on our score sheet. Yes, it is. Okay, level 6, our card game. So what we need to do is we need to call b1 hash. We want to drop those first 2 rows, and then what we want to wrap these so we can see what each player has. So wrap rows 2. We then need to see the numbers, so I'm going to use regex extract, trying to practice this. So if we take from that, we want any digit. There could be 2 because it could be 10. So we get our numbers, and we want to know the difference. I'm just going to use, I'm not going to use dynamic references here because we know it's a fixed number every time. So it's the absolute difference between taking one from the other. We also want to get the suits, which we can again use regex by just pointing at this and using capital D, because that's anything that's not a digit. And we get our suits. We want to know if the suits are the same. So basically, I'll use minus minus. Is this equal to that? And if it is, it returns a 1. If it is true, then the multiplier becomes 10 rather than 1. So we can then use 10 to the power of this. So our multiplier, and then our score is basically if the difference is 0, then nobody scores anything. Otherwise, it's the difference minus the multiplier. And if we sum those up, we get 70, which is our example. And that should hopefully follow through for all the others. We'll just double check. Level 6. Yep, well, there was only 10 levels on that, 10 questions on that one. Okay, level 7 is our kind of, it looks like a fruit machine to me, but it's not. So I thought I'd been really clever here, because I was like, oh gosh, you know, if I use my text characters on cell C1, nothing happens because each of these is longer than 1. So then I was like, oh right, I can use regex, and I need to get a funky pattern by combining all of these in, you know, separated by a pipe. But actually, we just need to use a single dot, because that is a wildcard and they all come out there properly. So yeah, there you go. Now I want to count how many times these appear in this list. Okay, so then we've got a count of how many of each one we had. The multiplier, you could, I overcomplicate this thinking it was cumulative, so it would be like multiplied each time, diminishing returns. But actually the easiest way to do this is just say 1.1 minus this times 0.1. And although that means if we had none of them, we'd be charged 1.1, when we multiply these out, that's going to be negated. So we're just going to multiply the multiplier times the number times the price. And then when we sum those up, we get 178614, which is should be our answer. We go to the case and we see that those are all correct. So now we go to the bonuses. How many letters are there in the names of the 20 travellers? So what I'm going to do is I'm going to count the occurrences of A in the upper concat of the names. I think that's 3 brackets. There we go, 18. What is the weather on the 1st of March? So this is where you have to be careful. So the 1st of March from here, we know the 1st of March is actually day 59 based on 0 indexing. So therefore, based on 1 indexing, it's day 60, which means it is rough weather. If you want to pass through all the cells in L4 Elephant tab, we just need to sum the map. What is the sum of all the values on the diamond cards? Level 6. So level 6, we're going to make some space over here. So let's 2col all of the answers, all of the inputs. Let's regex extract from this. We just use a wildcard, as we know now. I'm typing too quickly. And then we want to, what am I doing? We want to regex extract the non-digit, the suit. Then we want to filter this based on this equaling, where have I gone? Equaling, we can point to that cell because it's a diamond, so that'll work. And then we want to regex extract from here anything that is a number, could be 2 digits, so we need to put plus, and then we're just going to sum that range. Oh, I didn't multiply the regex by 1 to turn it into an actual number, and I know that's incorrect, so something has gone wrong. What have I got wrong here? So let's do this again. So we're going to filter all of the cards where these equal, I think something's, I don't think I've selected the whole range, have I? I have. So I've 2-called that. I've extracted those. Let's go, I think because I missed the 10. So let's regex extract on that with digits plus times 1. Now we're seeing some 10s, and then let's sum that. Still getting 326, which I'm pretty sure is wrong. So I'm going to just pause if that comes out as wrong. 326 and check where I'm going wrong. I've worked out it's going wrong. For some reason, I had some hidden rows here, which meant this was not pointing at the whole data range. And so when I do that, I'm just going to check, because I think I'm pointing at something missing. Okay, yep, and then that means I'm not pointing at diamonds, so I need to point at diamonds in that, and then we just sum that up and we get 589, which from doing this before I know it should be correct. And then finally, determine all the travellers who made it around the world in 80 days or less, excluding the example. And what caught me out here when I tried this and I had to ask for help was that on 2 of the questions, level 6 and level 7, it mentions that after getting to San Francisco, they travel 6 days to New York. So if you didn't get that, you wouldn't be able to do this. So what we need to do is we need to add those 6 days to this. So let's take this plus 6 times 1440 to get our final arrival minutes. Then let's take that and divide by 1440 to give our arrival times in terms of days. And we want to look at that and see how many of those are less than 80. And then if they are less than 80, let's grab the names, which I think are in the same order. I hope are in the same order every single time. So let's then filter our list of names where they are less than 80. And then if we concat, let's wrap this in a length and concat those, we get 51, which should be our final answer. And then just double check. I think we've got green ticks all the way down. So how are we doing for time? I actually can't see the time on here, so I don't know. So yeah, really good case. I really enjoyed it, though. Like I said, I made a massive mistake in my strategy in that I just soldiered on thinking I'm going to get level 5, and then didn't leave any time for the others. So I think for me, I will in future take my own advice and if there are easier levels later on, go on to them as long as they're not dependent on the previous levels, because otherwise, yeah, that's just a bit silly to do that. So, yeah, great case. Well done to those of you who did the landmark case. Well done to those who did really well on the community case. Please don't look up my score. It's pretty rubbish. I'm not happy with it at all, but there you go. All part of the learning process. Doing this, I find it very, very helpful. Forces me to learn things, practice things, and hopefully get a little bit better each time. So thanks for watching.